If you've spent any time on Math YouTube, you've probably seen this classic infinite radical problem 1,000 times. Everyone knows the trick. You just replace the inner nested part with the total value and solve a basic quadratic. Too easy, right? But what happens when we tweak the matrix just a little bit? Take a look at this. The square root of x plus 2 times the square root of x minus 2 times the square root of x plus 2 times the square root of x minus 2, and it goes on down to infinity, all equal to 5. Notice anything different? Look closely at the signs. It goes plus 2, then minus 2, then plus 2, then minus 2. It alternates. The standard copy-paste infinity trick completely breaks down here because the inner pattern doesn't match the whole thing anymore. If you try to solve this using your old methods, you are going to walk straight into a trap. Pause the video right now, try it yourself, and let's see if you can break the loop. Alright, let's crack this open. Since the pattern alternates, we can't just call the inside 5. We need to isolate things step by step. Let's peel off that first outermost square root by squaring both sides of the equation. This gives us x plus 2 times the square root of x minus 2 times the square root of x plus 2 times the square root of x minus 2 down to infinity equals 25. Perfect. Now, let's get that remaining big radical by itself. We'll move this x to the right side and then divide the whole thing by 2. Now we have the square root of x minus 2 times the square root of x plus 2 times the square root of x minus 2 down to infinity equals 25 minus x over 2. Now, focus deep inside this infinite square root on the left side of equation 1. Do you see it? Look closely at the nested part starting right from that inner plus sign. The square root of x plus 2 times the square root of x minus 2 down to infinity. That is literally our original question. And remember, our original equation was equal to 5. This is the absolute beauty of infinity. By peeling away just one layer of this alternating plus-minus cycle, our original question reappears like a ghost right inside the math. So, we can confidently replace that entire repeating section with the number 5. This transforms equation 1 into something beautifully simple. The square root of x minus 10 equals 25 minus x over 2. From here on out, it's just smooth sailing algebraic execution. To destroy that last remaining radical on the left, we are going to square both sides. This gives us x minus 10 equals 25 minus x over 2, all squared. Next, we expand the right side. The numerator becomes 625 minus 50x plus x squared, and the denominator becomes 4. Let's cross-multiply that 4 to the left side. Now we have 4x minus 40 equals 625 minus 50x plus x squared. Finally, let's move every single term to one side to form our standard quadratic equation. X squared minus 54x plus 665 equals 0. Now we need two numbers that multiply to 665 and add up to 54. With a little bit of factoring, we find they are 35 and 19. So we get two brackets, x minus 35 times x minus 19 equals 0. This gives us two potential answers, x equals 35 or x equals 19. But wait, in Olympiad math, you always have to check for extraneous solutions. Let's plug them back into equation 1, which was the square root of x minus 10 equals 25 minus x over 2. If we test x equals 35, the right side becomes 25 minus 35 over 2, which is minus 5. But a principal square root can never give a negative output, so x equals 35 is a fake solution. If we test x equals 19, the right side becomes 25 minus 19 over 2, which is 3. And the left side becomes the square root of 19 minus 10, which is the square root of 9, which is also 3. It fits perfectly. So there you have it. The final, elegant, absolute answer is x equals 19. Infinity loves to play tricks on us, but if you track the loop carefully, the math always uncoils beautifully. If you loved this twist, smash that like button, subscribe for more brain-melting math problems, and I'll see you in the next video.